Okay, so let's take a look at the solution to this problem. Again, we begin by selecting a representative rectangle from our region. As we have discussed previously, first we're going to determine these four quantities, x tilde being x. Y tilde is the average height of our rectangle, because remember, x tilde, y tilde is the center of mass of your representative rectangle. So who can tell me what y tilde should be? X cubed plus x over 2. As I was going around, I saw several of you had a minus sign. It's a common mistake. But remember, here you're finding an average height. If you have two y values, you average it out just like test scores, add them up and divide by 2. Okay, dm is the area, or rather the mass of your thin rectangle, which is density times area. So the area of that thin rectangle is the height times the width. The width is delta x. And how about the height of that rectangle? What is this distance? X minus x cubed. Okay? dm is the summation of all the masses, so basically integral of dm, small dm. That's what total mass equals. So to do that, we do density times integrate x minus x cubed dx. And how about the limits of integration? You would normally set x is equal to x cubed, and if you solve this equation, you're going to get x is equal to 0 or x is equal to plus or minus 1. But in the first quadrant, you can only take two solutions, 0 and 1. Okay, in the first quadrant. So this point right here is 1. This point is 0. So we're going to integrate from 0 to 1. So we're getting a half minus a fourth. In other words, just a fourth, or density over 4 is our total mass of the region. Now to find x bar, the formula was 1 over total mass times the integral x tilde dm. Okay, so 1 over total mass, that's 4 divided by density, right? What am I writing for x tilde? We did it earlier, right? Just x. And for dm, from up there, x minus x cubed times density times delta x, or it becomes dx. Again, densities disappear. So we integrate and plug in our limits. So if we get common denominators, we're going to have 5 minus 3, or in other words, 2 over 15 times 4, that's 8 over 15. Okay, any questions about this before we also get the y bar? Any questions about x bar? Anybody got that? All right, let's also the y bar. Very similar formula, right, to begin with. So 1 over total mass times the integral of y tilde dm. Now we look back to y tilde. That was x cubed plus x all over 2. X cubed plus x all over 2. And dm was x minus x cubed delta x times density. Okay. I'm going to factor the 1/2 outside. Now, how could I simplify quickly this quantity? X plus x cubed times x minus x cubed. That's difference of two squares, right? So x plus x cubed times x minus x cubed, that's going to be the same as x squared minus what? X to the 6. Or if all else fails, you can do the FOIL method. You can also do it that way. You could certainly do that, but I like to notice identities, and if I do that, I like to use those so that we learn them for a reason, right? Okay, so we've got 2 times x cubed over 3 minus x to the 7 over 7, 0 to 1. So here we're going to have 1/3 minus 1/7. And if you simplify this, I believe you're going to get 8 over 21. The final answer should be a unique x bar comma y bar, a unique point, which is 8/15 comma 8/21. Okay, any questions about this? We're going to do one more example. Any questions before we go on to that one? Yes, Joshua.
I don't know what again.
Okay, next example. Not that one, this one. Find the center of mass of the region bounded by y equals x to the 2/3 and y equals to 4. I did not give you the intersection points because I know you can find them by setting the two equal to each other. Also, before you go too far into the problem, to save you some time, once again, notice there is some symmetry here. And what will x bar be? It should be 0. Yes, you could do the entire integration process and get 0 that way, but if you notice it right away that there's symmetry, then the center of mass is going to lie along that axis of symmetry. So x bar is 0. You just have to worry about y bar. Okay, I'm going to give you a little bit of time to think about it. Okay, so y is 4, but we don't know what x is, right? So to do that, we need to solve a quick equation here. Let 4 be equal to x to the 2/3. An easy way to do this would be raise both sides to the 3/2 power. And this means the square root of 4 is 2 to the 3rd is 8. Now this gives you only the right-hand side one. And if you do the problem a little bit more carefully, you will actually find that it's going to be plus or minus 8. So negative 8 is going to be this side. When I say do it more carefully, like when you take the square root of something, it can be plus or minus, right? And basically by raising to the 3/2 power, technically we did take a square root there. So technically it is plus or minus. So basically first you raise both sides to the 3rd power, you get 64 is equal to x squared if you do it more slowly. And then take a square root of both sides, x is plus or minus 8. All right, we have the x value, but now we still need the x tilde, y tilde, dm, and total mass. Now x tilde we're not going to worry about because we know the final answer will be 0 for the x center of mass. I just put it there, but we may never need that. Okay, y tilde is the average height, which will be 4 plus x to the 2/3 all over 2. dm is the mass, which is density times 4 minus x to the 2/3 times dx. And total mass is the integral. Now, ordinarily, you would go from negative 8 to 8. But to save some time, and I see the symmetry in the region, I'm going to go 2 times integral from where to where? 0 to 8. Just to make it a little bit easier in the evaluation step. You didn't have to do it that way. I'm just trying to take a little shortcut. You could have gone the integral from negative 8 to 8, and the integral of dm, you could do it that way. Or double it and go from 0 to 8 instead. Okay, the integral is 4x minus x to the 5/3 over 5/3, or times 3/5, 0 to 8. Okay, what is 8 to the 5/3? First, you take the cube root of 8, right, which is 2, and then you go 2 to the 5th power, or 32. And I'll get common denominators. I have 5 32s minus 3 32s, that's 2 32s. So I get 1/28 density over 5 for the area, rather than the mass, because it's really area times density. Okay, any questions about the setup so far, how we set this one up? Yes, Krista? Okay, the 2, I put it there because instead of going from negative to 8, the actual region for this problem was from negative 8 to 8. So I did a shortcut. I went from 0 to 8, but then to compensate for it, I'm multiplying everything by 2. Okay. Okay, now we're not going to do x bar. Let's directly go to the y bar calculations. Okay, we know y bar is 1 over total mass times the integral of y tilde dm. Okay, y tilde, as we determined earlier, was the sum of the two functions over 2. So this is the y tilde, and the dm, that was the difference times dx times density. And the limits, again, ordinarily I should be going from negative 8 to 8. At the moment, let me put it as negative 8 to 8. Later, I can worry about if I can double this again like I did before. Okay, I will stop throughout the 1/2 so I can simplify the rest nicely. Now, what I have left inside the integral, let's use that shortcut rule that we were discussing with Joshua earlier, the difference of two squares, right? And that's what I have, 4 plus a quantity, 4 minus a quantity being multiplied, that same quantity. So it's going to be a squared minus b squared, right? What is my a squared here? 16 minus my b squared. Okay, when you're squaring it, you're going to multiply the powers, right? It will be x to the, what is x to the 2/3 squared? X to the 4/3. We multiply the powers. Okay. The densities really cancel. I don't have to carry them anymore. Could I go from 0 to 8? Now look what you have ended up with. And if it's an even function being, if you replace x with negative x, and you get back the same thing, then you can do the shortcut method. And this 4th power here, it will eat up all the negatives. That 4th power is an even power. If you replace x with negative x, it'll eat up the negatives. It'll disappear, make the negatives disappear. So this is an even function, and I can do that trick. I can go from 0 to 8 and multiply the answer by 2. And the 2's cancel. All I have to do is integrate. And plug in the answers. Okay, what is 8 to the 7/3? First, take the cube root. The cube root of 8 is 2. And then basically it's going to be 2 to the 7th power, which I can simplify in my next step. Again, I'm going to need common denominators. That's what I did. And at this point, you can really plug everything into the calculator if you wish. But I like to see if I can find some simplifications. And I do see something here. For example, 16 is 2 to the 4th, and 8 is 2 to the 3rd. So together that's 2 to the 7th power. So what we have is we have 7 times 2 to the 7th minus 3 times 2 to the 7th all over 7. So I have 7 of those minus 3 of those. So I'm left with 4 of those. In other words, 4 2 to the 7ths. And I note that 32 is 2 to the 5th, 64 is 2 to the 6th, and 128 is 2 to the 7th. So that 2 to the 7th will cancel with that. So I'm getting 20 over 7. Now, I don't expect you to do it this way. It's just my weird way of doing it. I like to see if I can, write things in powers like that. But you can always use a calculator if you need to. And make sure you get a decimal answer that is correct. So that would be fine as well. So if you got, instead of 20 over 7 as an exact answer, if you got 2.86, that would have been fine for this question as far as I'm concerned. 2.86. But give the answer in the complete answer. What is x bar comma y bar for this problem? X bar is 0 and y bar is 20 over 7. So that is our complete answer.